Okay? And these are just lots of different problems that you're going to want to have access to so that you can make sure that you're doing them right for your test. Okay, the first thing I have to do is I have to distribute. So I have 5 times x is 5x. 5 times negative 6 is negative 30. 3 times x is 3x. 3 times 2 is 6. Okay, I've got to get my variables on the same side of the equation. It's a good habit to get into to move it to the left. You don't have to move it to the left, but when we do inequalities, that is a better way to do inequalities. So if you get in the habit of moving it to the left, you're in good shape. So then I have 2x minus 30 equals 6. My next step is to add 30 to both sides. And we have 2x equals 36. And my final step is to divide both sides by 2. So my answer to this is x equals 18. Okay, so that is a relatively straightforward equation. Okay, can I move to the next one? Okay, so our next one also has distribution. So I have 2 times 3n minus 4 plus 3 times 2n minus 3 equals negative 2 times n plus 5. Okay, so we've got distribution that we've got to do. 2 times 3n is 6n. 2 times negative 4 is negative 8. 3 times 2n is 6n. 3 times negative 3 is negative 9. Then I have negative 2 times n, negative 2 times 5. Okay, now here I've got like terms on the same side of the equation that I need to combine. So before I move this negative 2n over, I want to go ahead and combine the 6n's. 6n plus 6n is 12n. Negative 8 and negative 9 is negative 17. Now that I combined the variables on the same side of the equation, I can start moving the variable to the left. So I'm going to add 2n to both sides. Negative 2n and positive 2n are gone. Over here I have 14n minus 17. Okay, now on the right-hand side, sometimes students lose that negative. Dropping negatives is a big problem, so be sure you're conscious of that and you're not dropping the negatives. So this is negative 10. My next step is to add 17 to both sides. So I end up with 14n, and then I have positive 7. So this is a negative number. I've got negative 10. This is a positive number, positive 17. Okay? The sign that I'm going to take is the positive sign because the absolute value of 17 is larger. And I subtract their absolute values because their signs are different. Okay? So making mistakes with positive and negative numbers is something that is a problem. Or is an issue that we sometimes forget how to do. So be aware of that. My next step is I divide by 14. 7 over 14 can be simplified. What is it simplified to? 1/2. Excellent. Okay. The next one that we are going to do has fractions. We've got numbers in the denominator, so we want to get rid of that. Can I move off the screen? Have we got it? Okay. Number 3. I have 2x plus 1 over 3 plus 3x minus 1 over 5 equals 1 over 10. Okay? So, I am looking for the LCD of 3, 5, and 10. So I am going to multiply the entire problem by the LCD of 3, 5, and 10. Now, at first, I might think that 10 is my LCD, but I can't use 10 because 3 does not go into it. So my LCD is actually 30. Okay? So I am multiplying by 30 over 1. So I have 30 over 1, and I multiply everything times that 30 over 1. So I have 2x plus 1 over 3. Then I have 30 over 1 times 3x minus 1 over 5 equals 1 over 10 times 30 over 1. My next step is to simplify, and when I simplify, I'm able to get rid of all of my denominators. And that's the goal, is to get rid of all your denominators. Okay? So 3 goes into 3 one time. 3 goes into 30 10 times. This 10 has got to be multiplied by the entire numerator. So now I have 10 times 2x plus 1. Okay? My 5 goes into 5 once. 5 goes into 30 6 times. And that 6 is multiplied by my entire numerator. So I have 6 times 3x minus 1. Okay? 10 goes into 10 once. 10 goes into 30 3 times. And so now I have 1 times 3. At this point, I can distribute. And I have 20x plus 10 plus 18x minus 6 equals 3. It's important to go ahead and combine these like terms. I've got 20x and 18x, and I've got 10 and I've got negative 6. Those are like terms on the same side of the equation, so I am going to combine those before I start moving things to different sides of the equation. So I have 38x plus 4 equals 3. Okay. My next step is to subtract 4 from both sides. I'm left with 38x. 38x equals negative 1. So I have 38x equals negative 1. I divide by 38. So x equals negative 1 over 38. And that is my final answer right there. And I know it's a fraction, and sometimes we don't like fractions. But fractions are good. Okay? Can I go to the next one? Okay. This one, a problem like this one on your quiz was what lots and lots of people missed. Okay? So I want us to be aware of this problem right here. So I have 5x plus 6 over 2 minus x minus 4 over 3. And this was probably, as of right now on the quiz, it's the one that people miss the most. This one and the triangle one. What I want you to be aware of, and what I really, really want you to focus on, is that subtraction sign. When I am subtracting these two rationals, that subtraction belongs to this entire numerator. So I am going to change this to plus, and then I'm going to distribute that negative. The problem on the quiz that was like this, lots and lots of students did not distribute that negative to both numbers. And that was where the mistake was. So I would encourage you to go ahead and deal with that negative from the very beginning. Okay, then I would have 5x plus 6 over 2 plus negative x plus 4 over 3. Okay, and if you deal with that negative from the first step, you're not going to have to worry about it later. So if you miss that one on the test, it is likely that that's where you missed it, was with that negative. I've got to multiply by my LCD. So I have a 2, I have a 3, and a 6. So my LCD for this one is 6. So I am going to multiply everything by 6 over 1. So I have 6 over 1 times 5x plus 6 over 2. Then I have 6 over 1 times negative x plus 4 over 3. And then 5 over 6 times 6 over 1. Okay? Now, I'm going to simplify, and what should happen at the end of this right here is I should get all of my denominators should be gone. So that is our next step, is to simplify. 2 goes into 2 one time. 2 goes into 6 3 times. Remember, this 3 is multiplied times my entire numerator. So I have 3 times 5x plus 6. Okay. Here, 3 goes into 3 one time. 3 goes into 6 2 times. And this 2 is times negative x and the 4. On the right side, the 6 cancels out, and I'm left with 5. I distribute. 3 times 5x is 15x. 3 times 6 is 18. 2 times negative x is minus 2x. 2 times 4 is 8. Okay, I have some like terms. 15x and negative 2x. Then I have 18 and 8. Okay. My next step, I'm going to subtract 26 from both sides. I'm left with 13x equals negative 21. And that's a little bit icky. Don't you agree? And it stays icky, but that's okay. Now I divide both sides by 13. And my final answer here is x equals negative 21 over 13. Any questions on this one? Any questions on this one? Nope. Okay. Okay. Now let's do one with decimals. Okay. Here I have 4/10 times t minus 6. That equals 3/10 times 2t plus 5. Okay? Now, here I have 1 decimal space, and here I have 1 decimal space. So what do I need to multiply everything by? 10. Because I don't have anything with 2 decimal spaces. So I just am going to multiply each side by 10. So I have 10 times 4/10 times t minus 6 equals 10 times 3/10 times 2t plus 5. Okay? 10 times 0.4 is 4. 10 times 0.3 is 3. Okay? I distribute. I get 4t minus 24. Whoops. 4t minus 24 equals 6t plus 15. I add 24 to both sides. Whoops, I actually probably would, it's okay if you added 24 to both sides. That's a completely fine way to do it. I typically encourage you to deal with the variable first. And I typically encourage you to move the variable to the left. It's just a good habit to get into. I realize that in this situation, you might not want to move the variable to the left, and that's okay. It's okay to move the variable to the right. It's just super helpful when you're doing inequalities to always move your variable to the left. So that is why I often say move your variable to the left. So I'm going to deal with that 6t, and I'm going to subtract 6t from both sides. And now I'm left with negative 2t minus 24 equals 15. Now I would add 24 to both sides. Okay, so I have negative 2t equals 39. And my final answer here is going to be 39 over 2, and that is negative. It's negative 39 over 2. Okay. Can I go to the next one? Am I good? Okay. Number 6. Number 6, we are solving for x. Solve for x. And this is a little bit of a challenging one, so I want to really talk about how to do this one. Okay. When students look at this one and they see solve for x, what they see pretty quickly is that a and x multiplied together, and they'll say, okay, I am just going to divide both sides by a, and then I'm going to get x equals bx plus c over a. This right here is not correct. Okay? That is not the correct way to do it. The reason is, do you see how I have an x here also? I have not solved for x if I have x showing up on both sides. So I can't do it this way. So the way that we have to do it is I've got to get that bx on the other side. Okay, so I'm going to start with ax equals bx plus c. I am going to subtract the bx from both sides. So I have ax minus bx equals c. Okay, so now I've got the x's on both sides. I've got the x's on the same side. They're together. Now I'm going to factor out that x. And this is tricky. This is where students get confused. I have to pull out that x, and then I'm left with a minus b. That's what I'm left with, is a minus b. Because x times a gives me ax. X times b gives me minus bx. So I have factored out that x. Now I divide by a minus b. Okay? And if you take Math 144, this is going to be something that's super important when you do inverse equations. Okay? So this is a skill that you kind of want to keep in the back of your mind. So when I have solved for x, I end up with x equals c over a minus b. And that is my final answer right here. Okay? And that one is challenging. I can understand that. Okay? Ready to talk about inequalities? No? That's okay. We're going to talk about them anyway. Okay. Number 7. Number 7, solve the inequality, graph, and write answer in interval notation. So I have 3 minus 2x is less than negative 5. Okay, I've got to isolate that x, so I'm going to subtract 3 from both sides. When I subtract 3 from both sides, sometimes students lose that negative. They don't want to deal with the negative, and so they end up dropping it. Okay, so be careful not to drop that negative. Okay, my 3's cancel, my 3 and my negative 3. I'm left with negative 2x is less than negative 8. Okay, I'm going to divide both sides by negative 2. Dividing both sides by negative 2. When I have divided both sides by negative 2, what happens here? Yes, I have to reverse my inequality sign. So it becomes, instead of less than, it becomes greater than. What's negative 8 divided by negative 2? 4. Okay? Now, I always encourage students to graph this on a number line first before they do interval notation because it helps them to see what the interval notation is going to look like. So I am going to put a parenthesis at 4, and it's greater than, okay? But my final answer is written in interval notation, and 4 to infinity is my interval notation. Now, the thing that students missed on the quiz was the bracket versus the parenthesis. When do I use a bracket? When it's the greater than or equal to or the less than or equal to. Okay? So on this particular one, the things that students forget is they forget to reverse the inequality sign because we're dividing by negative. Okay? So let's do another inequality. This one is a compound inequality. So this says negative 6 is less than 4x minus 5 is less than 6. This is a compound inequality that is combined by the word and. You can think of it as 4x minus 5, and 4x minus 5 is greater than negative 6. Okay, so 4x minus 5 is less than 6. 4x minus 5 is greater than negative 6. But the way that we solve it is that we isolate the x in the middle. We are isolating that x in the middle. That's how we solve this. And so we have got to get the x all by itself in the middle. Instead of doing it to 2 sides of an equation or 2 sides of an inequality, I have 3 sections. So I'm going to add 5 to all 3 sections. Okay, so I am left with negative 1 is less than 4x is less than 11. Okay, to get my x by itself in the middle, I'm going to divide both sides by 4. Okay, and I'm left with negative 1/4 is less than x is less than 11 over 4. Now, we have to meet both of these. We have to meet both of these. And this is one of the things where it's really super important that you do the number line first, because the number line first puts it in order for you. It helps you to see the order. So I have x is less than x is less than 11 over 4. And then I have x is greater than, because we're reading it backwards, negative 1/4. I am going to draw the number line. Here's 0. There's negative 1 and negative 2. Okay. Negative 1/4 is pretty close to 0. Okay. 11 over 4 is almost 3. And it is in between these numbers. Okay. This x, this part right here, if I were to rewrite that, do you see how my open part is towards the x? So that would be x is greater than negative 1/4 and x is less than 11/4. Okay? So my answer to this, my final answer, is going to be negative 1/4 to 11 over 4. This is graphing it. So what I did right here is graphing it. This is my answer in interval notation. The graph allows us and helps us to write it in interval notation. That's why the graph is helpful. You're not required to do the graph all the time, but it's helpful to do the graph because then you can get your interval notation correct. A lot of times students will have the 11 over 4 and the negative 1/4 reversed. And that is incorrect because it's not in order from least to greatest. Interval notation always follows the number line for left to right. So you're going to have your smaller numbers first. Okay? Can I go to the next one? And then we're going to hit a whole bunch of word problems. Okay. Solve the inequality and express the solution set using interval notations. So, I have 5x minus 4 is greater than or equal to 12, or 12x plus 5 is less than or equal to negative 4. So this one is combined by or. So we only have to meet one of the criteria. Okay? So I am going to add 4 to both sides. Okay, so I'm left with 5x is greater than or equal to 16. I'm going to divide both sides by 5. And I get x is greater than or equal to 16 over 5. For my second one, I subtract 5 from both sides. I'm left with 12x is less than or equal to negative 9. I divide both sides by 12, and I get x is less than or equal to negative 9 over 12. This is, and that can be simplified, right? What can it be simplified to? 3 over 4. Now, this is the reason that I strongly encourage you to do the number line. Okay? Because when I do the number line, so 1, 2, 3, 4. Okay. When I do the number line, and I've got x is greater than or equal to 16 over 5, 16 over 5 is just past positive 3. Okay, and that goes to positive infinity because this is x is greater than or equal to 16 over 5. Then when I do the x is less than or equal to negative 3/4, that's going to be about right here. Then I'm able to make sure that I get my interval notation in the correct order. So my answer to this is negative infinity to negative 3/4 union 16 over 5 to positive infinity. because of how this is written up here with the x is greater than or equal to 16 over 5, sometimes I'll have students do negative infinity to 16 over 5, union negative 3/4 to positive infinity. Do you see that? They just go in whatever order they get their answer, and they write it in that order, but it's incorrect. Whatever is on the left-hand side here has got to be the smaller number. So this right here is an example of why it is so important to always do the number line. The number line helps you to put them in the correct order, because this negative 3/4 has got to go first. Negative infinity to negative 3/4 has got to go first. Okay? Can I move off this screen? Any questions about that? Okay. Number 10. Yuri bought a pair of running shoes. So we're going to write Yuri bought a pair of running shoes at a 20% or 25% discount. Okay, the amount she paid for the shoes, okay, was $48. Okay, what was the original price of the shoes? That's what I want to know. What was the original price of the shoes? So, Yuri paid $48. So is the original price going to be more than $48 or less than $48? More. It's going to be more than $48. Okay? Now, if the discount was 25%, what percent did she pay? 75%. So Yuri paid 75% of the original price. And students forget to do that subtraction. That's where students make their mistake, is with that subtraction. Okay? So, how do I write how do I write 75% as a decimal? 0.75. Okay, of, what operation is of? Multiplication. Do I know what the original price is? Nope. But how much did she pay for it? 48. Okay, so now we are going to divide both sides by 0.75, and I'm going to show you the math on this. Okay, the 48 goes inside the box. The 0.75 goes outside the box. What do I have to do with that 0.75? Move the decimal. So I'm going to move the decimal twice. If I move the decimal twice, what do I have to do with the 48? Move it twice. So I actually have 75 into 4,800. Okay? And I should have moved it down just a little bit more. 75 will not go into 4, and 75 will not go into 48. Okay, so I'm just going to mark those off. Now, there's a little bit of guessing and checking here. 75 is kind of towards 80. How many times does 80 go into 480? 6 times, okay? We're not 100% sure that 6 is correct, but we're going to try it. So if I do 6 here, 6 times 5 is 30. 6 times 7 is 42, plus 3 is what? 45. Okay, so now that did work, so I can subtract that. Okay, I bring down my 0. How many times does 75 go into 300? 4. Okay, so the amount I paid, or Yuri paid for the shoes, is $64. Okay, when you're doing the practice test, when you're working on the classwork, when you're looking at your quiz, don't use a calculator because you won't be allowed to use a calculator on the test. Okay, so you don't want to practice using a calculator. Okay? Okay. Now, we have scores on a test. We have Tan. Tan has scored 52, 84, 65, and 74 on 4 different math tests. Okay? He needs an average of 70 or better. Okay? He needs a 70 or better to pass the class. So if I wanted to find out what Tan's average is right now, if I want to know what Tan's average is right now, what do I do? Good. So 52 plus 84 plus 65 plus 74. And then what would I divide by? 4. Okay? That gives me his average right now. What I want to know is what does he have to get on the 5th test? Okay? I don't know his score on the 5th test, but I want to know what does he have to score in order to pass the class. So I'm going to add an x here. When I add that x, what do I have to divide by? 5. And he has to be greater than or equal to what? 70. Okay? Now, this is where students make mistakes. Students almost always add these up and they do fine with that. So if I add all these together, I get 275 plus x over 5. And that's greater than or equal to 70. How do I get rid of that 5? I can't divide. I've got to get rid of it. I'm going to multiply. So I'm going to multiply by 5 over 1. Okay? Here, that cancels. I have seen many students then take this 275 plus x and they turn it into 275x. And I'm not sure why. Okay? So this right here is plus x. So when you add all that together and you multiply both sides by 5, it's still plus x. It's not times x. Okay? So I'm not sure what's happening there. That students get confused. We're still adding that 5th score to it. So what I do is I subtract 275. So what does Tan have to make on his test? Yeah, he's got to have a 75 or better. Okay? 75 or better on the test. 75 or better. Okay? We've got time for one more. Okay. I have a rectangle. Okay? The width of the rectangle is 1 inch more than 1/4 its length. Okay? The perimeter of the rectangle is 42 inches. Okay, so the first thing that I would do is I would draw a rectangle. Okay, I would draw a rectangle. I've got my length and I've got my width. The width is 1 inch more than. How do I write 1 inch more than? Plus 1. Okay. How do I write 1/4 its length? 1 over 4 what? 1 over 4 L. Okay. So this is L right here. And this is 1/4 L plus 1. The equation for perimeter is 2L plus 2W. Okay? So I've got 42 equals 2 times L plus, what did I figure out the width is? What do I plug in for W? Good. 1/4 L plus 1. Okay? Now we're going to have to deal with some fractions. Okay, so I have 42 equals 2L plus 2 times 1/4. That's 2 over 1 times 1 over 4. What does that give me? 2/4, and 2/4 is? Good. So that's 1/2 L. 2 times 1 is 2. Okay? So now I have 42 equals 2L plus 1/2 L plus 2. Now, it really depends on what you want to do next. It's reasonable to multiply everything by 2. If I multiplied everything by 2, what would happen to that 1/2? It would cancel out. Okay, so it's completely reasonable to do that. Some students will be like, nah, 1/2's not that hard to deal with. So I'll change my 2 over 1. I'll change that to 4 over 2. What happens when I change 2 over 1 to 4 over 2? What happens there? Is that the same thing as 2? Yes. Okay. So then I have 42 equals 5 over 2L plus 2. Okay. I'm going to go to the next screen so that we can keep going here. 4 over 2 is the same thing as 2 over 1. Okay? So I have changed this right here to a common denominator. Okay? So 2 over 1, I've changed my denominator to 2. 1 goes into 2 2 times. 2 times 2 is 4. Good question. Okay? So now I'm going to rewrite this. I have 42 equals 5 over 2L plus 2. So I'm going to subtract 2 from both sides. I get 40 equals 5 over 2L. Anybody know how I get rid of a fraction? Multiply by its? Good. Okay, so I've got to multiply both sides by its reciprocal. Okay, and when I do that, this cancels. I'm left with L. 5 goes into 5 once. 5 goes into 40 8 times. So my length is 16. Okay, that's my length. My width was 1/4 L plus 1. What's 1/4 of 16? 4. So 1/4 times 16 is 4. So what's my width? 5. Okay, and my inches. Okay, so we have 16 inches and 5 inches. That was something that people missed on their quiz, is they forgot to put units. So be sure you're putting units there. Okay? Okay, this is another word problem. So we've got two cars leave the same place at the same time, traveling in opposite directions. One car is traveling at a rate of 30 miles per hour, while the other is traveling at a rate of 45 miles per hour. How long will it take until the cars are 250 miles apart? So what we have here is we have a destination like Montevallo. And so here are the two cars. One car is going this direction and one car is going another direction. So one of the cars in an opposite direction is going 30 miles per hour and the other car is going 45 miles per hour. Okay, so we are going to use rate times time equals distance because we are told that our distance is 250 miles, our total distance. So if we take the distance that this car travels and we add it to the distance that this car travels, we are going to get 250 miles. That's what we're going to get. Now, our time is the same. So they're both leaving at the same time and they're both traveling the same amount of time. We're just trying to figure out how long it's going to take them to get 250 miles away from each other. So what I'm going to do is I am going to have 45 miles per hour, that's my rate, times my time is going to equal the distance of this car one. Okay, so whatever car is going 45 miles an hour, 45 times t is going to equal the distance of that first car. Now, the same is true for this other car. So I have 30 miles per hour times whatever time that I'm traveling is going to equal the distance of the second car. Okay, but I want to know the total distance, and I do know the total distance. The total distance is 250. So if I add the distance my first car travels to the distance my second car travels, then I'm going to have the 250 miles. So my equation that I need to solve is 45t plus 30t equals 250 miles. Okay, so that's my equation that I'm going to solve. So I am going to move on to the next screen and solve that equation. So I have 45t plus 30t equals 250 miles. So 45t plus 30t is going to be 75t, and that equals 250. I divide both sides by 75, okay? And when I do that division, what I end up with is 3. So 75 goes into 250 3 times, okay? And actually, I should put that over my 0. Okay, so 75 goes into 250 3 times. So 2 times 75 or 3 times 75 is 225. Okay? Now, I have a remainder of 25. Now, I can handle this in lots of different ways. Okay? I can put a decimal. Okay? And I can say 75 goes into 250 3 times, and I can continue to repeat that pattern. And I see that I have a repeating decimal, so I can continue to repeat that pattern. And so I have 3.33 hours. The other thing that I could do is I could say, since I've got a remainder of 25, I could say 3 and 25 over 75. And that is 3 1/3 hours. So I will accept 3.33 repeating hours. I'll also accept 3 1/3 hours. I will also accept 3 hours and 20 minutes. Okay? Because 1/3 of an hour is 20 minutes. And so that is an acceptable answer too. So I'm going to put 3 1/3 hours, or 3 hours and 20 minutes, or 3.33 hours. Any of those answers is completely acceptable for that.